Okay.
All right, so we have gone live.
So I go just show my video once, then stop video.
That's fine. That's fine.
Yeah, because
All right. All right. Good morning, good afternoon, good evening, wherever you are, everyone. It's good to have you join us again for another wonderful series. Uh, this is one of our series on Microsoft Azure DevOps development and a few other things like that. In this series, we'll be looking at how you can architect modern web application using ASP.NET Core and Azure. I believe that we have a lot of people building various applications, various things like that with .NET. Probably you even building with other technology stack, right? And you would like to understand how can you then deploy, right, those systems, those applications to the Microsoft Azure platform, right? This particular training is going to bring us into that particular knowledge, that particular understanding. And it's going to be a wonderful time. We're not going to waste your time. We're just going to go into the criticality of things. It's going to be four different sessions. So we're having our first session today, and then we'll be having next session tomorrow, and then next week we would be back again to finish up the session. So stay tuned with us. Um, if you have questions, I will be with you here on the chat session. Looking at your questions and all of that. You can also send us um, your questions at our email address, which will be placed on the screen for you much more later. All right. Without further ado, we have one of our senior engineers, Ekene Ama, all right, who with myself will be taking us through this particular training session, all right, and it's going to be a wonderful one, all right. So, Ekene, hi, how you doing? You can unmute your mic. Hello, how you doing?
hi, thank you very much. I'm doing great and I'm excited to be here again. We had it last year and we are here again on another level.
I'm
This
telling
is
you,
for the
fantastic,
developers. Last year were for
fantastic,
DevOps engineers. Now we
exactly,
want to do it for
fantastic.
developers.
Yeah, we had we
So
and
thank you for
we had good responses last year because a lot of people reached out, talked about the training session. It was very impactful for them. It was really a good one, really a good one. All right. Without waiting much of your
okay.
time, I'm just going to hand over to Ekene as we kick off today's session. All right, Ekene, please take over. Thank you.
Okay, thank you people. Um we are glad to be here again. We are here for the developers. I'm a Kene Ama and a senior .NET developer. More specialized in anything backend. I don't like showing my face. That's why I don't like front end. So anything backend from where backend starts, from the coding to infrastructure to pipelines to VMs to database, anything that you don't see on the front end. That's where I play. I'm not that good in front end because I don't know how to size a square. I don't know how to make a square straight. I don't know the difference between green and lemon. so I can't do front end. So thank you. Welcome to this session, architecting modern web applications with ASP.NET Core. It's going to be an exciting sessions. It's going to be 4 sessions, 2 hours each. And today we are going to start. Just today is going to be a talk to get you on board. What is .NET? What is Azure? Then, well, as we go forward, we'll now delve deep into the development, where we'll look at microservices, how to develop architect a microservice application, how to deploy it, how to monitor it, then how to scale it, because that's all about Azure Cloud. So we'll develop, and we'll scale, and we'll monitor. So thank you. So let's get started. So confirm you can see my screen. Section 1, Introduction to Modern Application Architecture and .NET on Azure. So it's going to be a 2 hours class, 2 hour
We can see your
session.
screen. Yeah.
So I'll just run us through the outline for this first session, which is the first session is greeting, brief overview. We'll go to understanding modern application architecture. We take us 30 minutes. We'll now go to introduction to .NET and Azure. We'll introduce you what is .NET and what is Azure. We'll now go to key concepts in .NET development, understand some key concepts. Well, understanding .NET Core and its advantages, then explain common architectural patterns. They will now go to overview of .NET Core building. We may not go exactly as it is. We'll do some tweak. We don't take it off since it's a live class. We may not do it as a recorded class. So we may not follow as it is. But this is the whole concept which you get. Then setting up your development environment, which is then we go to Q&A. So simple, straightforward. So that's our outline for today's session. So we'll now get started. So was now overview of traditional voice model. We try to look at it in some various aspects of characteristics, monolithic based microservices. Traditionally, they had microservices where everything was just lumped together. If you're an old developer, you've heard of WinForms, where everything is joined together, and where you cannot separate it. One application is just everything. So modern now goes to microservices, where they had to start separating things. Let's separate things. Let's not put we can You can have an application where one part is built with .NET, another part is built with Java, another part is built with Ruby on Rails, another part is built with Node.js, but they're all serving one application. So that's how you think of microservice. It doesn't mean because it's .NET, everything is built with .NET. You can build with anything you like. You can have developers in Kafanchan developing their own. You can have developers in Guangzhou developing their own. Everybody is developing his own, but there is for one goal. So that's microservice. Everything now was separated together. Separation of container. You're think of distributed systems. That's what we talk of microservice architecture. Then another advantage, look at scalability and flexibility. If everything is joined together, like all of us are under one umbrella, if anything happens to that umbrella, all of us get wet because we are all under one umbrella. So if everything is joined together, you cannot scale. You know why microservice comes is microservice plays a very good role because of the cloud. Cloud is expensive, but if you are running on your own data center, your enterprise data center locally, you just afford to buy a server. So scalability is not a problem to you. You just buy a server and scale things up. But but in the cloud, everything is expensive. Everything is money. So you have an application that is about 10 let me say an application which is about 1 gig. Yeah. So if you want to scale this application now, the version needs one it's running on one VM. So just the registration page, because it's Christmas, it's a Christmas season, it's a holiday season, many people are registering. So just that particular model has a lot of hits, which is people are registering always. But you want to scale it. So you now have to start scaling the whole application just because only one model is having a lot of traffic. So, and you are not going to spend so much by either you're scaling up or you're scaling out. Yeah, either vertically or horizontally. So either you're adding more VMs, you're adding more resources to the VM. That's you are now going to spend so much money. But what if I have all these services running in various small VMs or web or app micro Azure App Service, or they are running on containers? So I can decide that okay, this small container, which is just the registration module that has to handle registration, this is the one having a lot of it. I'll just scale that part. I will not need much to scale it. So it will just scale easily and gradually, and I can scale up, I can scale down without affecting other aspect of the application. So that's scalability. Then flexibility, I can decide to change. Okay, my registration page, the registration model is slow. What is better? I'm using Node.js. Okay, want to use .NET. We can change it from Node.js to .NET without, while others are still running their own application. Okay, we have our developers have changed, our developers have moved, and we have a particular model which we need to change. You can just affect doing that model. But if it's a monolith, you will need to start. If you want to, you can't move from .NET to Node.js without you are writing the whole application, so it's not possible. So you have scalable and flexible architecture allowing components to scale independently. So we've talked about that. Then another advantage, you have deployment model. Traditional, you deploy the single unit, everything, the whole is deployed. It's very big. You cannot test it. You cannot make changes. Testing becomes very difficult because you are deploying something very big at once, and your pipelines will always break because of network. And worse still, you are doing it from Nigeria. You can imagine what will happen to your application every time you're deploying your pipeline will always break because of network issue. Nigeria is a peculiar case. So you have that challenge, but if it's a microservice, you're deploying just small, little by little packages at any given time. So you have limited issues coming to breakage in transmission. They have technology stack. As I said before, you can have different types of technology in one application based on their developers and based on the market need, based on what is out there, based on what is trending. You can change it at any time because they are scattered all together. You separate them, and so you can have different tools, different languages for different models. Then what of resilience and fault tolerance? So traditionally it's susceptible to failures because if one part fails, everything fails. If just one part break, the whole application break because they are all modeled up together. But in microservices, modern application idea is so that one part can break without affecting the other part. That's for fault tolerance and resilience. So they are more resilient. They can accommodate downtimes, they can accommodate errors, they can accommodate issues that will come up either through infrastructure or through usage. So that's resilience and you can and fault isolation. Fault isolation, here you can say that okay, where is the error really coming from? You can say, okay, is it the registration module? Is it the sales module? Is it the customer module? So you can isolate your fault. You can make sure your fault is coming from a particular. But if it's monolith, you don't know where it is coming from. If you have ever written win forms before, you will understand what I'm talking about. Something will break. You will check the .aspx file. You check the aspx.cs file. You check the BLL. You go to the BLL. You go to the DL. You go to the XSZ just to find where an error is coming from. I bet you don't wish to go in those days. When the days of WinForm, that's where we started. We started with WinForm, we started with Visual Basic. But then when we were building WinForms, we were the top guys in the class then. We were like, you build your first WinForms, you just get your form, you drag and drop in. The application is good and going. So it was exciting. I'm not writing bad about WinForms. It helped us pay our bills back then. It was good when it was there. But now times have changed. So you have to, it's serious debugging issue. But with microservice, we just look at it, this service, this is down, then let us fix it. So that's fault isolation. So this is a simple sketch I did for a microservice Please, can you see hear me? Please confirm if you can see hear me.
Yeah, you were muted for a minute, but yes, we can hear you now.
Okay. So you see your client apps is Internet of Things. You can have web, you can have mobile, you have Internet of Things, you have robots, whatever are your client. Then there's an API gateway. So this is the guy who talks. Then you have your different services. So you have your UI on this client part. You have the UI running on this client part. Then you have the API gateway, which you can be Azure API gateway, or you can develop your own API gateway. They have your different services. This is example of an e-commerce application. You have the catalog service, you have the shopping carts, you have the discount, you have the ordering. So different services, you can break them based on the architecture which you have chosen. Then there is the messaging bus. So how does this talk to each other? They talk to each other through the messaging bus. But the catalog does not know there's a shopping cart. Shopping cart does not know there's a discount. Discount does not know there's an ordering. Each of them have their own separate databases, but they talk through a messaging bus. This messaging bus is can be a pop and stop messaging bus. So you just tell it, and this one picks it, and it doesn't care who is saying it. It doesn't know where it's coming from. It just knows that there is a message, and it picks it. So this is a messaging bus that talks to each of the microservices. So I'll now take walk us through an e-commerce microservice architecture. So this is said. Let's walk through an e-commerce microservice architecture. Um, an e-commerce platform built on microservice architecture. What's an start the e-commerce platform is designed using the microservice architecture to ensure scalability, flexibility, and resilience. Please keep these three words in mind when you're talking about modern application architecture: scalability, flexibility, and resilience. These are the three things that makes us go to the cloud. These are the three things that makes us want to be modern: scalability, flexibility, and resilience. Because this is the modern age. This is how application work. This is what application face. So if your application cannot meet these three, it becomes very traditional. It becomes very difficult for people to use your application. Just imagine that your application is down. You know how much you will lose. They'll just switch over to the next one. Simple. There is no stress. If you come here and it's down and it's giving you issues, you switch to the next one immediately because there are so many out there and you won't want that. So now, what are the components? We have the user interface. The user interface is where you have your forms, we have everything on the UI. Your like button, your cart button, your submit button, your all the controls are on the user interface. Then you have the authentication service, which handles user authentication. This is just an example. You can have more based on your own architecture. Which handles user authentication and authorization, then utilizes OAuth or JWT token for secure authentication. So you have your that's one service. Like if you are using Google, if you want to log in, every application of Google goes through one registration service. There is one authentication service. Like even if you are using Microsoft, login.microsoft.com for all of its 365 for all the applications, you have to go through that URL login.microsoft.com, just like for Google. So it's the same thing here. There is one service that manage all your authentication. All it does is once it authenticates you, it sends you to where you are going to. So you have one authentication service, then you go now to you have your product catalog service. So for those people want to view your products, there are times like let me say during Christmas, this product catalog service will be highly hit because so many people will come to view. So you can't tell me that because many people are viewing my food on the product catalog, I should now scale the whole application of say 10 gig. So NASA scaling the whole application of say 10 gig because of just one service. That's not proper. So I'll just like okay, scale just the product catalog service. This is where manage product information, including listing, search, and details. They have stores product data to on scalable database like Azure Cosmos DB and MongoDB. They have the shopping cart. service, where people add and remove items to the shopping cart, tracks user shopping cart, and manage the cart related operations, stores cart data in distributed caching system like Redis or Hive for high performance. So that's your shopping cart service. You have your order management service. They have inventory service. They have recommendation service. So there are various services which you can have. So if you want to architect this, you look at the from your BRD, your business requirement document. It's from there you now decide which service, how you now break your architecture to fit which service. It comes on the BRD. You look at the whole picture, you now break it down into. You can decide to break it based on modules, or you can decide to break it based on requirements. So it's all left to you to find a way to break down things so that you have um, um there is the solid principle is well followed. You understand the solid principle, which one of them is single responsibility, which is the S. That's the basic part. So microservice builds on the solid principle, and the S for solid is single responsibility. So you have your jeez. Hello, am I still audible?
Loud and
Hello.
clear.
Okay. So, any questions so far? So I'm not sure.
No question so far. Yes, no question. No question so far. So let's we can continue. No question so far. Okay. So I think can everybody hear me? For those in the chat, drop a chat if you can hear my voice and you can hear me. Yeah. Okay. Fantastic. So okay. All right. All right. So I see we can hear me. Good. Uh,
Mm,
all right. So welcome back, Ekene. We can hear you. We can see you. Please proceed.
okay, thank you, thank you. So we've talked about the component. So let's talk about architectural highlights for this e-commerce. So what are the things we are highlighting if you have architected your microservice application, your application in this using a microservice architecture. So you have your loosely coupled services. They will say each service is developed to and deployed independently. As we said before, you develop deployed independently. The ordering service doesn't know there is a chat service. The chat service doesn't know there is a recommendation service. The recommendation service doesn't know there's a shopping cart service. So every service is running on its own. They have the API gateway, which is a centralized API gateway to manage please permit me. I'll have to stop my video to manage this empty network. Please just permit me. Okay. So you have loosely, then you have your API gateway. So the API gateway does so many things. It does rate limiting. That's where you handle rate limiting. You handle authentication. You handle other session management. You handle sessions at the API gateway. Then there are rate limiting to make sure that people are not hitting your service to manage all the DDoS. Then on your API gateway also you manage things like georeferencing to make sure that okay, I want people from USA to service to go to this particular application. So you do all those in your API gateway where you want to make sure that people from particular geographical region does not they meet a particular service. So the API gateway does a lot of things for you because that is the entrance, but it doesn't do any business logic. It just mainly for it's a pass through and for checking to see that who is good to go into your services. Then there's the event driven communication, which we showed before. The event driven communication, which is the service bus, the messaging bus, where each microservice can talk to each other. Service communicate asynchronously by messaging queues or event streams, ensuring decoupling and fault tolerance. So the card service want to talk to the ordering service. If I go to the order, or if let me say on the product catalog page, I, I send to cart. I'm on that page. I've clicked to add to cart. So that product catalog page will send the message to the cart service through the service bus that an item has been added to cart. So the cart service now will now add it to the user's cart, and then it will now send a message back to the catalog page to display it that this food is added to cart. So you see, all of them are talking through the service bus. They are not on the same application. Like if you go to Jumia, you may think it's not the same application. All those things are different services running differently. If I now click on the cart from that ordering page, you now go back to cart bar and display the cart for me. So they're all so everything is managed through an event. You send the message, what is called pop and sub. So you publish a message, it goes to a queue, and the subscriber picks the message from the queue. So you hear something of pop sub communication, publisher subscriber. That's the meaning of pop sub. Then let's go to another architectural highlight. We have containerization. So each service is packaged as a Docker container, allowing for consistent deployment and scalability. So what Docker container does, so if you have anything containerized, so I can move it to any platform, I will not be worried. If I can move that same Docker container to AWS, I'm not worried about the infrastructure on AWS. I'll not be worried that it is working on Azure, it's not working on AWS. It's working on GCP. It's not working on Azure. As long as I've containerized it, it works in any environment I'm going to put it because it's a container. If you carry a Mares container from one ship to the other, the item inside does not change. This is why they ship. So see Docker as the ship. Then there are different containers inside. If you look at the Docker logo, it's like a dolphin carrying containers. So it's a ship carrying containers. So if I have a Mercedes Benz in a container, which is inside a particular ship A, and I take that container to a ship B, the Mercedes Benz is still a Mercedes Benz. This is why they ship. If I take that same container to ship C, the Mercedes Benz is still inside. So it doesn't change no matter the ship. So that's how Docker works. So if I have my Docker container, if I take it to any platform, my application is still running. It doesn't change. So that's a very basic way to explain to you how Docker containerization works through Docker. Then Kubernetes now is the guy that makes sure that okay, um, we want to have replications, or if the ordering service, which is inside a particular container, there is much heat on it. So how do we scale it? So Kubernetes is the guy that will add more of the ordering service. So if the traffic is low, it will now delete some nodes and reduce it back again. So that's what Kubernetes does. It includes for scaling and for scaling out and for scaling in. Then you have monitor and observability. Because it's a it's a microservice, I can easily monitor each service very well because what I'm looking at is very small, unlike in a monolith. So comprehensive logging, monitoring, and tracing are implemented using tools like Azure Application Insight, Prometheus, Grafana, and open source tools for monitoring and observability. Also, you have ELK stack for visibility into application performance and health. So these are architectural highlights. They have scalability. Then what are the benefits from microservice architecture? Scalability. We have mentioned it. We cannot overemphasize scalability when it comes to advantages of microservice architecture. It is highly scalable. It scales with it, then it's flexible. Changes and updates to specific services can be deployed without affecting the entire system, promoting agility and innovation. So underline this word, agility and innovation, and that's what the cloud stands for. The cloud stands for agility and innovation. So you can decide to change anything in the cloud, unlike the days when you need to have on premise and data center. Before you change anything, you have to go to computer village to buy a server. Before you can start your small business, you think of buying a server, you think of a server room, you think of networking, you think of employing at a server admin. But in the cloud, you just spin up, just go to your browser, just need to have browser and internet, then you spin up whatever service you want to spin up. So it promotes agility and innovation. Then you have resilience, fault isolation and redundancy built into the architecture, ensuring high availability and fault tolerance. So because of its spread, you can afford to have 99.9999% uptime, because you can try to put your microservice in different regions. Microservices doesn't mean all of them must be in different regions. You can say that, okay, which particular people are high at this particular time. So you separate them in different regions. You can use various redundancy, zone redundancy, job redundancy, zone job redundancy, the various redundancy architecture which Azure offers, and that will give you 99.99% uptime. So for microservice architecture. Now, so any questions so far about microservice architecture and all we have been talking so far? Any question? Ayo.
No, no question yet on the chat. I'm following. There's none. There's none yet.
Okay. So now want to introduce into what is .NET and Azure. We have gotten the whole concept of microservice. Now I want to go into .NET. What is .NET? .NET is a framework. .NET framework is a powerful and versatile platform for building a wide range of applications from web, desktop to mobile and cloud-based solutions. And you all know it was developed by Microsoft. But when it was developed, it was not fully open source. It was only when Satya Nadella came come in and start talking of more collaboration, that .NET become an open source through .NET Core. But .NET from the beginning was not open source. But now they have opened up .NET Core and it's now open source. So it provides comprehensive set of tools, libraries, and runtime environment for developers to create robust, scalable, and secure applications. When Java came, Java said they can run any and everywhere because they have their Java runtime environment. So you can build with Java and it will run on Linux, it will run on Windows, it will run on Mac, as long as you have the Java runtime environment on that machine. So Microsoft, in order to beat the market, because they're the B2B and they always think very far, they decide to say, okay, let us do .NET. .NET to come with its own CLR, Common Language Runtime. So that's what I say, okay, write in any language. .NET supports Python, supports COBOL, supports Perl, or supports J, JScript, supports C Sharp, support Visual Basic, support F Sharp. So a myriad of applications, a myriad of tools, a myriad of languages. So write in your own languages and let us run it for you on any platform. So if I'm building an application, I don't need to worry about let me compile it on Mac, let me compile it on Windows, let me compile it on Linux. You don't have that worry. So .NET gives you that tool. Are you a C Sharp developer? Develop on C Sharp and we'll run it for you anyway. Develop develop once, run everywhere. So that's a .NET um, mantra. So you develop once and run anyway. So this is architecture for .NET. So you see up here, you have your C Sharp code, your F Sharp code, your Visual Basic code, and other Python, COBOL, Perl, as I mentioned. Then you have the compiler. The compiler now down into a common intermediate language. So no matter where you write, everything comes down to this common intermediate language. Whether it's F sharp, whether it's Visual Basic, whether it's C sharp, they will all come down to the same code. At this point, you don't know where it is coming from. At this point, at this CIL, you don't know whether it is C sharp, whether it is F sharp, whether it is Visual Basic. All of them are the same. Then you have the common language runtime. This is the guy that does a runtime. So when you build, remember with your Visual Studio, you are not you are not compiling, you are building. So when you build, it comes down to this level. So this is what gets deployed on your server, your dear level. Then it's when the program, if somebody starts the program, if you look at your C sharp application, you have that startup.cs or program.cs. When the program starts, then it is now compiled by what is called just-in-time compiler. And the just-in-time compiler sits inside common language runtime. This common language runtime holds several things. It holds garbage collector. It holds the just-in-time compiler, and that is what will take it to machine code. So once the program stops, all the machine codes are cleared from the memory. So it saves space and memory. So you can have a .NET application run your system, but it will not using space unless you are running it, because it's not a machine language. It's not compiled. It's compiled at runtime. Once it's the file will sit there, it's only when it is running that it now change converts to machine code. And once it stops running, the machine codes are all clear from memory. So that's something you should know about .NET, the basic, because you want to get to the mindset of an architect. So you need to understand the fundamentals of .NET, how .NET works under the hood, because that is how an architect think. When you think of architect, you always want to know how does it work under the hood. Because that is where troubleshooting starts. I bet you if you don't know it to this level, you may not troubleshoot some very detailed issues. There are some crazy issues which, unless you understand how the tool work under the hood, how things are work behind the screen, done behind the screen, you cannot troubleshoot some very critical issues. So please get this clear how it really works. So that's this architecture for .NET. Then we go now. Let's the key concept. We have the common language runtime. The CLR, it's is the execution engine for .NET framework, responsible for managing memory handling exceptions and executing code written in various .NET language. It provides features like automatic memory management, which is garbage collection, then and type safety and security. So that's what the common language, what we showed before, this common language runtime. In Java, you have the Java runtime engine. Before you can run any Java application on the system, you must put the Java runtime engine. In .NET, we have the common language runtime. So I'm just like trying to tell you that compare two things so that you are to broaden your knowledge. If you're coming from a Java environment, know that you can still do the same thing with .NET. Then we have the base class library. So base class library are shareable libraries which you can share between languages. I can with the base class library I can share a class from C sharp to F sharp to Visual Basic. So these are classes which Microsoft has written that can be shared among languages, so that you can develop faster and easier. So it includes classes like your IO. So anytime you are writing an application and you do something like using system dot, just know that you are calling a base class library. So I'll show you some example of a base class library. System.io. Most times all application, if you just start an application in, in Visual Studio, you always see at the top system.io. So if you just see system.io, it means you're using a base class library. So what does this do? File stream, stream reader, stream writer, file directory, input and output if you have to work with a form. from keyboard. If you want to pick information from keyboard, you use system.io. If you want to write to screen, you use system.io. So that's a base class library. So it doesn't matter whether you are using Visual Basic, C sharp, F sharp, or whatever. So system.io is a base class library which is shared among all languages. Then you have something like system.collection that handle array lists, list, dictionary, value, queues, and stack. That's system.collection. Then you have system.u. There are several others which you can browse for to at least to get some more technical knowledge. So you are not just using things, you are understanding why you are using what you are using. You may go for an interview, they ask you, okay, why this? You may see some, they say, why is it not running? You don't know that, okay, because there is no using system.trading. So you need to really understand how this works. There are several of them which we will not have time to go through. We need another class to understand these libraries and know why we use them. Then we have the common type system. So you know the types in .NET. CTS is responsible for understanding the data types of .NET programming language and converting them to CLI. That's common language runtime, understandable format. That is value type. So example of common common type systems. You have your integer, all your data types. Yeah, let me not use big grammar. It's called data types. Common type system manages data types. Your integer, your boolean, your string, your date time, your decimal, whatever data type. So both primitive data, mostly primitive data types. So that's what this particular system manages: float, double, string type, and the rest. So your common type system manages all your data types. They have your garbage collection. It is used to provide automatic memory management. So before .NET, we had C Sharp 6.0. That's the last C Sharp before .NET, C Sharp 6.0. So if you are writing in C Sharp 6.0, you have to do your memory management. Like if we are using Java before the Java VM was introduced, we if you can you do a lot of memory management, especially like now currently C. If you are using if you write in C and C++, you handle your memory management yourself. So anything you have to do, you have to clean your memory. Otherwise, you have memory leak in your application. But in advancement with .NET, we you handle your they handle the memory cleaning for you. For example, look at this code. I have I declare an integer, an array of integer of say 1 million, of 1 million characters of integers. Then I now pass it into this variable number, into this array. It will be very big. Then if I want to clear it, I just say numbers equals to null. I've cleared that memory. But if I don't have a garbage, an automatic garbage collector, I will need to come and add another line under here called garbage collection.clean, gc.clear. I must come and use gc.clear to clear the memory. But once I just put null here, the memory is clean. I've cleared the memory. So that's what you should know about garbage collection. So you don't need to worry about garbage collection again because it is handled for you automatically. Once you leave a class, once a class stops running, garbage collectors come in and clear everything, all the variables that class was using from the memory. So any variable or any object which is no more in use is cleared from memory. So it is a very strong tool and it has taken a lot from developers. If you use, as I said, C Sharp 6.0, you start with Java, C and C++, that's where you really see the pain it is in memory management. It's very painful. If you have to develop through that route, you know how pain it is to really do memory management. So that then we now have the just-in-time compiler, which I talk about, which is part of the common language runtime. So it's responsible for converting the common intermediate language into machine code or native code using common language runtime environment. So that's the guy that comes. It takes your DLL, dynamic link libraries, and convert them to machine code. After you deploy your application, when you deploy, when you build the application, it comes out in a DLL format. Then this guy now picks that DLL and convert them to machine code, the just-in-time compiler. So this is what it does. So example now, I have a C sharp, a simple C sharp application. I've called my system. This is C sharp. It can be it can be Visual Basic, it can be F sharp, but this is C sharp. I'm conversant and okay, and I'm within the C sharp environment, so I'm always okay with C sharp. So now this is the just in then this is this is the CIL, common integrated language. So you have your IL, intermediate language. So all your languages, be it F sharp, be it C sharp, be it Python, will come to this CIL, common integrated language, intermediate language. So this is what your DLL looks like. Look at this. This is what your DLL looks like under the hood. Then once it's like this, then the just in time will now pick it up from here. Once the application starts, it will now pick this guy and now convert it to a machine language. So this is how the just-in-time compiler works. You have your C sharp, Visual Basic, JavaScript, F sharp compiler. This is at compile time, what you call building. When you build, if you are running your application, you build your application. This is what comes out at build time, and this is what your Excel or your DLL files. This is it. At this layer, you have your .exe or .dll file. This is what is deployed on your server. Your your pipeline deploys this on your server. Then once the application starts running, the just in time takes this DLL and convert them to native code, and then they're executed. The ones that are executed, once they're done, the just in time compiler saves everything back. So everything works with a just-in-time compiler. So this is the structure of a just-in-time compiler. As an architect, you need to understand this. It gives you it improves your troubleshooting. It improves your when you're writing an application to know everything about .NET and how it works. Now that's that for .NET. I don't know if there's any questions so far. Anybody has any question? If you don't want to type, you can still just raise your hand and or type in your question if you have any questions so far. Let me just give 5 minutes for that.
Mm, so yeah, there's no question for now. I think everybody is following keenly.
Okay,
Mm-hmm. So there's no question for now. Yeah.
okay, so let's move. We have now, let's introduce Azure Service relevant for application development. We have talked about .NET. So we are, because the whole thing is architecting solutions for .NET, using .NET and Azure to architect modern solutions. So we are now with the Azure now. So what are the services on Azure which you can use for your application development? You have the Azure App Service, which is a fully managed platform as a service where you can deploy your application. So Azure App Service supports a wide range of applications: .NET, Java, Node.js, Python, PHP, React, Angular, and the rest. So you deploy it on Azure App Service and it runs on it. So, but it's very broad. It doesn't just end there. There are several things we need to do to get the applications run on Azure App Service. So, based on with time, we will now as time goes on, we'll take Azure App Service and explain to you how Azure App Service runs, what is under the what because we like talking under the hood. We'll now look at what is under the hood of Azure App Service, what makes Agile Accept what it is. So we'll get into all those training in our subsequent training. So just stay with us, keep watching our
our handles, and you always be alert when we come up with new trainings. Then it supports they have features includes automatic scaling. You don't need to manage the scaling yourself. You just need to set it. When my traffic is above 10,000, 1 million, so it manages it for you. Then deployment can be done through CI/CD. You can deploy to Azure App Service from your pipeline, your GitHub Actions, your Azure pipeline, your AWS code deploy. So you can manage, you can deploy to Azure App Service. Then there is built-in monitor and diagnostics. You don't need to add any extra monitoring system to it. It comes with a built-in monitor and diagnostic service attached to it. So and it's very cheap. It's one of the cheapest, it's among the cheapest way of deploying your application when you want to start. So it's very cheap, it's affordable, and it's free for for your first 1 year. And when you have your application, your light when you buy your Azure service for that first 1 year, it's always free. So then you go to Azure Functions. Azure Functions here is a very small application which is built to do a particular thing. Is different. Azure App Service is platform as a service, while Azure Function is function as a service. Function in this case is that you cannot because except you have to build several functions. If you want to build a full-fledged app with function, then you have to build several functions to manage that application. So, excuse me. So you build functions handle just one specific instruction. Either if there's a new file, take that new file and dump it here. If there's a new file, pick that file and put it in different formats and in different sizes. Like Facebook, if I drop a file in Facebook, it will tell you create a rectangular shape, create um, create a portrait, create a landscape, create a circular. So that's what that function will do if there's any new file. So it can be triggered by any file upload, it can be triggered by message queue. If there's a message in the queue that is like that says that has stringify on it, this is what you should do. So it is triggered by a message queue. It can also be triggered by HTTP. So we can still say, okay, people, you can still call the function through HTTP from your browser, or you can call the function through an API. You can through a REST service. You can use the function as a REST service, so that from a UI it can be reached. It enables building microservices, event-driven architectures, and serverless applications with minimal overhead. So that's one advantage of Azure Functions. They have Azure Kubernetes service. As we said before, it's used for container management and orchestration. To manage your containers, so Azure Kubernetes service, developers can leverage AKS to deploy and manage containerized applications with ease, ensuring scalability and reliability. So if you want to scale up or scale in your container, Azure AKS is where to go. They have Azure Container Service. It's another tool also for deploying application. If you want to have your applications in a container, as I said, container is where if you container your application, you can run any and everywhere, whether it's AWS cloud. But if I deploy the application in Azure App Service, it may run on Azure App Service, but that does not guarantee that it will run on AWS. You get, because it's not a container application. If I put my application in a container and it runs on Azure, I will be rest assured that that same application can run on AWS. That's the one advantage of containerizing my application. So it provides flexibility and choice in orchestrating containerized workloads, enabling developers to deploy and manage applications seamlessly across a variety of environments. The underlying word here is variety of environments. You see the underlining word here for container, variety of environments. I can deploy it on any environment at any given time. Then I have the Azure storage. You can't do anything on Azure as a developer without Azure storage. If you are doing Azure App Service, there's Azure storage. If you are doing Azure Function, there's Azure storage. If you are doing Azure Containers Service, Azure ACS, there is Azure storage. If you are doing database, there is Azure storage. Under the hood, everything, as long as you are bringing in data, as long as you are bringing in data into Azure, there must be Azure storage. So Azure storage is under the hood of everything you're doing on Azure, as long as it involves data. Your code is a data. I hope you know that. Your code is a data. So you are bringing in your code into Azure. So you must have Azure storage. So it has various. You have Azure Blob storage, which is used for the meaning of blob, binary large object. That's the meaning of blob, binary large object. You have the Azure files, which is where if you want to move your system to Azure, use Azure files where you do your lift and drop. If you want to carry your application from on-prem, you have your legacy data and you want to move them to Azure. So you can use Azure file system for lift and drop. Azure file store. So that's what if you want to, if you are building your VM and you don't want your hard disk to be within the VM and you want your disk to be outside the VM, so you can use Azure files. They have Azure Queue, also which is for messaging services for reliable asynchronous communication between application components. They have Azure Tables. So Azure Tables is a NoSQL table where you can also use to manage your data. They have the Azure SQL databases. So this one you have all the SQL database, MySQL, Oracle, MS SQL, Postgres. So all of them fall under Azure SQL databases. So if you spin up Azure SQL database, you see you can choose any of these SQL databases. Then you can use Azure SQL to build data driven. So then at the Cosmos DB now is the NoSQL type of database for Azure, like a MongoDB. So provide comprehensive SLAs for throughput. It supports multiple data models, including document, key, value graph, and even time series database. So you have the Azure Cosmos DB. It is another tool you need to know when you're building for Azure. So then you have the Azure DevOps, which is it's a collection of tools. It's a set of cloud-based tools. Under Azure DevOps, you have Azure bots, you have queries, you have Azure pipeline, you have Azure repository, you have artifact. So Azure DevOps is a collection of tools which you can use to manage your software development life cycle. So you have everything in one platform. Then it enables things to plan, build, test, deploy, and monitor applications efficiently, streamlining the software development lifecycle. So you have for Azure DevOps. They have the Azure Monitor. Remember, we are looking at the tools relevant for application development. So you need to, if you want to start architecting solutions for Azure, you need to know these tools. Then you can now do which one to choose when you are to build your application. Because you are working from .NET, so you need to start. Okay, this my application. Which way is it going to when it is going to the cloud? You have the Azure Monitor. It's a comprehensive monitoring solution that provides insights into performance, health, and Azure resources and applications. So and every tool, every service in Azure, you have the Azure Monitor attached to it. Whether it is app service, whether it is function, Azure function, whether it's Azure Kubernetes, whether it's Azure Container Service, you have Azure Monitor on all of them. So you can use Azure Monitor to monitor all of your services. on Azure. It offers a metrics log, alerts, and dashboard for monitoring infrastructure, application, and services. So in alert, you can still tell it to say, okay, when there is an issue, you can send an email. So that's what Azure Monitor can do for you. When there is a downtime, you can test your APIs. Once an API is not reachable, you can send an alert, an email to whoever is in charge to handle that. They have Azure Application Insight. So this now is mainly just for applications. Why Azure Monitor can be used for all services. You can use Azure Monitor for blobs for Azure storage. You can use Azure Monitor for Azure database. You can use Azure Monitor for your key vault. You can use Azure Monitor for your Active Directory. But Application Insight is just mainly for your applications. Applications which are running on Azure App Service or Azure Functions or Azure Container Service. So this one is specifically for applications. So there are two ways you can incorporate it. You can incorporate it in your code, or you can incorporate it in Azure. So most times it is always good to incorporate it in your code so that you can have granular telemetry and granular information about your application, how it is running. But if you do not apply it on your code, you can now decide to apply it on the Azure, and that will also give you telemetry and also metrics information, telemetric and metric information about your application. It provides real-time insight into the application performance and user experience. So if a page is not loading, to tell you that your front this particular page is not loading, to tell you that this API is not reachable, to tell you that this API is taking a very long time to be reached. It can also tell you that people from Bangladesh cannot reach your application. People from Japan cannot reach your application. So it can give you all this telemetry based on how you configure it.
Hello, Ekene, can you hear us? All right, everyone. Let's wait for a few minutes for
Oh,
Ekene. Hello, can you hear us now?
yeah, I can hear you.
All right, we
So
can hear you also now.
you have the Azure Active Directory, which is a good tool for identity management. So currently it's called Azure Intra ID. So that's the latest name now. It has been changed from Azure Active Directory to Azure Intra. So that's what you use for identity management. You use it for your login. You use it for authentication and authentication for your application. So but you can also use that to do your normal VBAC, your normal roles-based access and control. You can start to do your own authentication, but if it's Azure, it is very strong, very reliable. For your OAuth 2.0 authentication, you can also use Azure AD to do your OAuth authentication because it's very reliable, it's scalable, and it's very highly available. Then what are the advantages of .NET and Azure together for building scalable applications? What are the advantages? So seamless integration. .NET is the first class citizen for Azure ecosystem. So you cannot beat my child. I'm the landlord of the house, and this is my child. So my child obviously knows everywhere in the house. So it is very seamless and very easy if you're using .NET on Azure. We are not saying that other tools are not good, but at least there's what they call branding right. Bragging right. So this is their bragging right. This is their space. And like if I cannot go and beat Oracle database in Oracle Cloud. If I have MS SQL and I go to Oracle Cloud, I cannot go and say MS SQL without perform Oracle database in Oracle Cloud. You get. I cannot go and say if I go to Google Cloud, I cannot go and say BigQuery, which is one of Google Cloud. Um, Azure um, an Azure service for big Azure or Spark cannot go and beat BigQuery on Oracle Cloud because that's their space. So that's what you're saying here. This is .NET. This is its space. Azure is its space. So you cannot beat it easily. It has a lot of advantages. So that is why if you are bringing your application to Azure, building it with .NET is just a better choice. So therefore, they have several tools and libraries to build and deploy applications on Azure without significant modifications. So it makes life easier. So you can have more time to go on vacation. And at least you build the application by December, you are free, you are on vacation. So you should not be coding in December while you need to be on vacation. Then scalability. Azure offers a wide range of scalable services. So that's one advantage of Azure. Azure has the B2B space. Most businesses are on Azure. So it is good for you to know Azure because that's a B2B space and the B2B market at any time. I always quote one of my very good mentor when it comes to tech, Hilary Aben, who always say at any given time, if in any space where a B2C is prospering. Once a B2B comes in, a B2B will always beat that market. So that even though AWS got into the cloud world before Azure, but because Azure is a giant in B2B space, Azure has beaten AWS in the cloud business. In the mobile market, in the whole internet market, Apple was leading, but recently, Microsoft is a leader in the largest company, above $3 trillion now in the world. So B2B will always be. So if you stick with Azure, if you grow with Azure, you will never lack a job, and you always have a job with the enterprise. And those are the guys that have the money, the guys that can pay you for the leave for every little effort you put in, you can make good earnings. So Azure has a lot of advantages for West, and Microsoft is largely behind it. Then you have global reach. Azure has a global presence. So in Africa, in Middle East, in Asia, so there's a global presence in Azure. So you can be rest assured that your applications can reach any user anywhere. And remember, that is Microsoft mantra. That is Satya Nadella motto for Microsoft to make every person and every company and individual to be able to do what to do more. So Azure is giving you that capability to be able to do more. They have high availability. They have 99.99% availability based on architecture you choose. Security. It is Azure offers robust security features including identity and access management, encryption, and threat detection. The .NET application can leverage Azure Active Directory or Azure Intra as the case now for authentication and authorization. So if you want to leverage Azure AD, it is easier implementing Azure AD with .NET than with Node.js. I've tried it many times. It's very easy. You don't need to start importing any new library. It's very easy in implementing Active Directory connection with with .NET than with Node.js. Try it and you see that it's seamless. And Active Directory is very easy to implement, very robust, very secured. It's one of the most um, secured identity management system out there in the cloud. They have cost effectiveness. If it comes to cost, Azure is very cost friendly, and you don't have unnecessary hidden charges, unlike other cloud platforms. Azure is cost effective and very good cost management. They have one of the best cost management tool out there. Then developer productivity. You can develop faster, easier, and with ease. These tools streamline development, testing, deployment, and management of .NET applications on Azure. So then the ecosystem has a very large community. The community is growing rapidly with .NET. Uh, Sorry, please. Let me see something. Okay, so the next slide now, I want to show us, if there are no questions, I want to take us. So that's the advantage, and that's all for now on the talk. We want to take you now to Azure, where I'll show us some of these services. So thank you very much for listening. Let's now go to Azure, where I'll show us some of these services. So let me get you to Azure platform. Just a minute. Let me open the Azure platform.
All right, while that is going on, if anybody have any question, you can drop in the chat. You can just reach out to us on the chat if you have any question at all, and then we'll be glad to answer them for you. All right. So, like we said, it's a first session. So stay tuned with us. We'll take it through step on step tomorrow, and then next week, likewise also. All right.
So this is the Azure platform. You have your services here. If I say create a resource, so Azure calls it resource while AWS calls it services. But let's stick with Azure, which is resource. So you see a list of resources. You have virtual machine, web app, SQL database, Key Vault. These are the resources you can create on Azure. There are thousands of them. You can choose from anyone you wish. So for for our own case, we are looking at the first one. Let me just show you app service. So if I type app service, the first one I'll discuss, which is Azure app service. So I can now choose app service plan or app service. So I'll now choose Azure app service. This is web app. I'll create my plan, web app. So I will now go ahead and create it. It will be in our next class. So I'll just show you what to require your subscription. One. Oh, okay. So this is just app service. We will not go much into it for now. It will be in the next class. Then if I go back, you have the Azure function. If I just type Azure function, so in case you have any question on it, I can still answer you. Sorry, I just have the function. So this is the function app. So you click to create a function app. So you put your function app name, your version name, your region, the operating system. So it can be a function app on Linux or Windows. They have your development stack. Your function can be a .NET, Node.js, Python, Java, PowerShell, Python,
Okay, Ekene, I think we lost you. Mm. Hello, Ekene, if you can hear us. All right, let's just wait for him to join back, everybody. All right, so we'll just wait for him to join back, everybody, and we'll continue. Okay. Okay, all right. All right. Welcome back, everybody, from that break in transmission. Ekene, welcome back. Can you hear us now? Hello, Ekene, can you hear us now? All right, I think he's having some technical issues. Just a minute. Let me try and loop him in again. All right.
Hello, Ayo. Hello, hello, hello. Can you hear me? Okay, thank you. So please, sincere apologies. I had to change network. I told you before, MTN has not really been helpful for a while now, and I had to switch network, and that's what really happened. So, sir, thank you for your patience. So I don't really know at what point I went off. Okay, okay, thank you very much. So I thank you for that. So okay, let me share my screen. So okay, so I'll just like trying to talk about the function app. So this is our function app. We have our resource group. I won't go much into function app. In our subsequent class, we'll talk more on developing the function app. So, but these are just what's required to build the function app. We have function app. We have Azure storage. I'm just showing all the things we have. We have the Azure storage. This is Azure storage where we talk about. I'm just showing us the the resources relevant for application development. So so thank you. That's the services we need. But when we go deep into the application development, we'll not go into those services. So our next session, so these are the services we'll talk about. What would you say? There are several of them, but with time, I will not start going through each of them now. If you have the slide, while we share the slide, you now look at the various services, and if you go to Azure, you easily see the services there. We will not have time to start explaining in detail those services because our function, our main focus is application development, how we architect our application for Azure. So we look at our next class, we go into building the microservices with .NET Core and Azure. And so the duration is 2 hours. So I'll leave this duration there. So duration will be 2 hours for that class tomorrow. We'll go deep in depth in building our microservice application. We'll look at patterns, we'll look at the various patterns that are involved, look at various development standards, we'll look at best practices. So our focus tomorrow is going to be on best practices and patterns on how to develop applications with .NET Core. And our focus is going to be on microservice. We have all agreed that microservice is the modern way of application development, not monolith. But instead, but each microservice is a monolith. That's just so microservice is just many monoliths all together. So it's a kind of a monolith. So each microservice, because it has its own database, it has its separate database. So it's a kind of a monolith, each application. So we'll now see how we develop each of these applications, the best practices to follow. Then the next class, we are in this class we also deploy the application to Azure DevOps. In a subsequent class, that's next week, we are going to look at monitoring and scaling, where we monitor the applications and we scale it, and then we'll do some other troubleshooting within the application. Then the final class will look at security and access control for the application. So that will be the end of my from me from this site. Ayo, you can take over. That's the end for me for today. Thank you.